Hello students, so let's learn law of sines today, okay? So here we have our notes. We use law of sines, this is law of sines, to find a missing angle or missing length, whatever the case may be, using when there is a situation where you have angle side or angle side angle. So you can use this law of sines to find the side and angle measures. Okay, so what is this law of sines? It is sine A over A equals sine of B over B equals sine C over C. Okay, so this is law of sines, and let's use this law to actually find the missing measures in this particular triangle. Okay, so let's see how this works. So we have here a triangle. Let's call this A, B, and C. So we'll know that the side opposite this angle A would be the lowercase a. The side opposite angle B is lowercase b. The side opposite the angle C is the lowercase c. This is the side. So what you need to do is, since the unknown is b, so we have to involve that. So sine b over x. And the other two knowns are 47 degrees and its opposite side 15. So we should involve that. So it's better to, so there is no information about angle C or the measure C. So we'll use sine B over B. So this part, okay, just this part. So we have here sine of 47 degrees over 15 will be equal to sine 104 degrees over B. So when we cross multiply, right, so we'll just cross multiply in a single step. What we would get, I'm using this space here, B would be equal to, you're switching sine 47 and B, and you're multiplying 15 to sine 104 over sine 47. Now you just use the calculator. Any calculator, scientific calculator, will have sine, tan, and cos. So you can easily find this value, and it's going to be 19.9 centimeters because everything is in centimeters. So B's value is 19.9 centimeters. Okay. All right, so same way we'll find, we'll actually probably go to the, let's do the fourth one. Okay, so the fourth one here is 32 degrees, 35 degrees, and x. We have 14 yards, which is opposite this angle. And we need to find that angle, which is easy. It is, first you have to do B, let's call that B, okay? So if this is A, B, and this is C, so measure B is given, and we need to find measure C. That's what it is. So we are using sine B over B, but what is B? B is 180 degrees minus of 32 plus 35. So that would be around 113 degrees. Okay, so this is 113 degrees. So what you need to do is to sine 113 over 14 yards. So 14 equals sine 35 degrees over x. That's it, and you just cross multiply just like how we did in the previous example. So x would be 14 sine 35 degrees over sine 113 degrees. So all of this would be about 8.7 yards. Okay, rounding off to the nearest tenth. All right, so that's how these problems go, and there is a word problem here, so let's quickly look at that. A pilot begins a flight traveling 80, so there is a figure here, 80 miles northwest. To avoid storm, he makes a turn, and a diagram of his flight course is shown to the left. Find the total distance of the flight. So here, let's first find the missing angle, as always. So you would do 180 degrees minus of 108 plus 15, so it comes to be 57 degrees. Okay, so this is 57 degrees. All right, so we found that, and the side opposite to 57 degrees is 80 miles. So let's first call the corners A, B, and C. C is the starting point. So we can actually say, to find the whole travel distance, we need to find this unknown measure, which is, let's call that lowercase b, because it's opposite angle B. So let's set up the equation according to the law of sines. Sine B over B equals sine A over A. So let's substitute the value. Sine B is sine 108 degrees over B, which we need to find, equals sine A is 57 over 80 miles, right? So we'll just cross multiply as we always do, right? So this would become B equals 80 sine 108 over sine 57. Okay, it comes to 90.7 feet. No, miles, my bad, it should be miles. Okay, so that's one thing. And the next thing we need to find, because he's saying total distance of the flight, what else is missing? We need to find this AB, which is, let's call it X for now, or we can actually call it C. Let's call it C. Okay, so we'll come to that. And so here we will do another sine. So we'll do sine 15 degrees, take some known, which is sine 15 degrees, which we know, and X is the unknown. I should have written C, my bad. But 15, I wrote it as 5, sorry, and equals sine 57 degrees over 80. All right, so again, we'll just cross multiply, and this will become 80 sine 15 degrees over sine 57. Okay, so that would be X equals 24.7 miles. So we got this. Now we need to find total distance. The total distance would be, now we found all the measures of this triangle. So total would be 80 plus 90.7 plus 24.7. It comes to be around approximately 195.4 miles. Okay, so that's what it is. And let's move on to the next kind of problems, which is side, and angle. You see that? Side, and angle. So which means you have to find the fourth angle normally. So, but this is an ambiguous case. Why? So when finding angles, it is possible to have 1, 2 or no solutions. So how does that work? So let's look at that. The sine function is usually, the value of it ranges between -1 and 1. Okay, that's the standard. It cannot go overboard. So angles with a positive sine function value can lie in the quadrant 1 or 2, the first quadrant or the second quadrant. To find the other possible angle, we must subtract from 180 degrees because it's positive between the first and second quadrants. The sum of the angle measures in a triangle is always, of course, 180 degrees. So no triangle can have two obtuse angles. So these are the points you should keep in mind when we are doing these problems. So let's look at this ambiguous case. So here we have measure A and measure of angle A, AB and BC. So let's first draw the triangle, okay? A simple triangle, not a big deal. Okay, these are the cases where the angle may or may not have a 90 degrees, okay? So this may not be a right triangle. So here he's saying measure of angle A is 60. So this is 60, okay? AB is 30 inches and BC is 27 inches. So he wants us to find measure of angle C, okay? So we'll use our law of sines here. So sine 60 over the opposite measure is 27. So 27 equals sine C, because we know the opposite end, which is 30 inches. Sine C, we need to find C over 30. Okay, so now we'll cross multiply. This is a simple cross multiplication. We just need sine C equals 30 sine 60 degrees over 27. Okay, so yeah, so this will come out to be C equals sine inverse sine of all this 30 sine 60. You can actually directly enter this into the calculator just like how you're writing it here. Okay, but make sure whenever you press sine, close a parenthesis around 60 degrees when you're entering in the calculator. So you will have one value to be 74.207. I'm going to write the decimals also here. So remember from what we learned above, to find the other possible angle, we must subtract from 180 degrees. So we have to subtract 180 degrees minus 74.27, which happens to be 105 degrees 0.794. So what you need to do is we first need to check if there is a possibility of two obtuse angles here. So 60, which is the other angle, 60 plus 74, let's round it off to 74, must be less than 180 for this triangle to be same. Otherwise it'll be you cannot have two obtuse angles. So these measures must be less than 180 degrees, which is the case. So our check is fine. Let's try with 105 also. Right? So this is also less than 180. So this is also passing the check. So which means this is a very well formed triangle and our answers are valid. So we'll have two answers, 105 degrees and 74 degrees. So we'll have two answers for this. So either it could be this or that. But there are cases where that may not be possible. So we will try that in the class, but we'll do the same procedure like how we did here for every other problem. Okay, when the check is not valid, that's when we say that this triangle is not possible, when you'll find two obtuse angles in a single triangle, which is not a possibility. All right, thank you for watching. I'll see you next time.